Funicular railways. Engineering marvels on steep slopes. A funicular railway is a specialized cable railway system created to navigate steep slopes. In contrast to conventional trains that depend on the friction between wheels and tracks, funiculars operate with counterweight cars linked by a cable, making them perfect for mountainous or hilly landscapes. These distinctive railways have consistently intrigued both engineers and tourists due to their straightforward yet efficient mechanics and scenic locations. A funicular railway is a specialized cable railway system created to transport passengers or goods along steep slopes. It generally consists of two counterweight cars linked by a cable. When one car rises, the other descends, effectively balancing the load and reducing energy usage. Key characteristics: operates on a steep slope, often up to 45 degrees or more. Uses a cable-driven mechanism powered by a stationary engine at the top or bottom. Cars run on parallel tracks, connected by a single cable loop. Designed for short distances, typically under 1 to 2 kilometers. The concept of a funicular is based on straightforward physics. The descending car's weight assists in lifting the ascending car. A cable drum, powered by either an electric or hydraulic motor, manages the movement. However, due to the counterbalancing nature of the cars, the energy needed is minimal in comparison to that used by elevators or traditional rail systems. Safety features often include automatic braking systems, fail-safe cable mechanisms, guide rails to keep cars stable. Funicular railways have their origins in the early 19th century. Among the earliest examples is the Reisig in Salzburg, Austria, which has been in operation since the 1500s, initially utilizing wooden rails and human labor. The advent of modern funiculars occurred in the 1800s, coinciding with the growth of industrialization and tourism across Europe. Notable funiculars worldwide. Montmartre Funicular, Paris, France. Connects the base of the hill to the famous Sacré-Cœur Basilica. Peak Tram, Hong Kong. One of Asia's oldest and most iconic funiculars. Duquesne Incline, Pittsburgh, USA. Offers views over the city's famous three rivers. Jelmabahn, Switzerland. Among the steepest in the world, with gradients up to 106%. Funiculars are used for urban transportation, in hilly cities where roads are impractical, tourism, providing access to mountains, viewpoints, or historical landmarks, industrial use, moving goods in mines, dams, or construction zones. Advantages: energy efficient due to counterbalancing, low environmental impact, safe and reliable on steep slopes, compact footprint compared to roads or elevators. While efficient, funiculars are specialized and not suitable for all terrains or distances. Key limitations include high initial infrastructure cost, limited passenger capacity, fixed route, no flexibility in direction or expansion. Though rooted in older technology, funiculars continue to be modernized. New systems feature automated control systems, panoramic cabins for tourism, integration with urban transport networks. Cities like Istanbul, Medellin, and Lisbon have recently revived or expanded funicular lines as part of sustainable urban mobility plans. Funicular railways exemplify enduring engineering that harmonizes simplicity, sustainability, and practicality. Whether transporting tourists to picturesque mountain peaks or acting as essential transport connections in hilly urban areas, funiculars continue to be an effective and delightful component of the worldwide transportation scene. This presentation is brought to you by Untold Facts from Maroli Edutech. Thanks for viewing. Please share and subscribe to our channel. Stay tuned for more informative videos.